This question says the angle of theta is located in quadrant 4 and cosine of theta is equal to 9 over 19. What's the value of sine of theta? And we're going to use a combination of SohCahToa and Pythagorean theorem to get this answer. It's going to be right triangle trig. So I'm going to start off by writing a right triangle. There's our right angle, and then we could put theta down here in that corner. And it wouldn't matter, you could put it up here too, but I'm going to do it down here in the bottom right. So we're going to start off by labeling this right triangle with the information that we were given. And we were told that cosine of theta equals 9 over 19. Now, if you look at our formula for SohCahToa, this is saying that cosine is going to be adjacent over hypotenuse. So really, this is going to be A over H. So the adjacent side is 9, okay? And the adjacent side to theta right here is 9. And then the hypotenuse is going to be 19, okay? So again, 9 right here, that's the adjacent side. And then 19 right here, that's the hypotenuse. Okay, so we have those two sides labeled. The next thing that we want to do is find this side right here. That's the unknown side. And we need that side because we're looking for sine of theta. And the formula for sine of theta is going to be using the SO part, okay? That's going to be opposite over hypotenuse. So we need the opposite side over hypotenuse. And we have the hypotenuse ready, right? We just knew that was 19. So I'm going to put 19 here on the bottom. But now we need the opposite side. And the opposite side of theta is always the side that you could draw an arrow and hit it. So x is going to be the opposite side. All right, and we don't know what that is. So that's when the Pythagorean theorem comes into play. We're going to use a squared plus b squared equals c squared. So one of the legs is x. We're going to square that, plus the other leg right here is 9. We're going to square that, right? Remember, this is going to be a leg, and that's going to be a leg. And then that's going to be set equal to 19 squared because that is the hypotenuse. It's always set equal to the hypotenuse squared. So go ahead and let's work to get x by itself. 9 squared is 81. 19 squared is 361. We could subtract 81 from both sides. We're left with x squared equaling, this goes away, that's going to be 280. And then we want to get rid of the squaring, so we square root both sides, and we're left with x equaling, this is going to be plus or minus the square root of 280. Okay, now we can simplify that a little bit. You think, is there a perfect square that we know is a factor of 280? And there is. That's going to be 4. So we could rewrite the square root of 280 as the square root of 4 times, I believe that is 70. Bring down the plus or minus. And then the square root of 4 is equal to 2, and then we still got the square root of 70. And that's going to be our answer here. If we bring down, oops, let me erase that. If we brought down this x, that's what x equals, plus or minus 2 times the square root of 70. So then I'm going to plug that in up here for x. That's going to be plus or minus 2 times the square root of 70 over 19. Okay, now we have to determine, is it going to be positive or negative? Okay, now we go up here and look at the question, and usually it'll tell us what quadrant theta is in, and that's quadrant 4. So let me go down here. I need to make some more room. Okay, this is quadrant 1, this is quadrant 2, this is quadrant 3, and then we're left with quadrant 4 down here. And this is where theta is located. Because we are working with what? Sine, right? It says, what's the value of sine of theta? We have to figure out, all right, well, is sine going to be positive or negative in the 4th quadrant? And remember, when we have a point, x comma y, we can match up cosine of theta, comma, sine of theta. Okay, so it looks like sine is always going to be paired with the y value. And we know that all the y values in this quadrant down here are going to be negative. So sine of theta is going to be equal to a negative 2 times the square root of 70, and then that's all over, what did I say, 19, right? And this is going to be our final answer. Now, sometimes people get confused about, like, wait, why is that negative again? Well, let's say if I had you graph a point and it was 3, negative 2. Okay, the x value is positive, the y value is negative. So if you're going to graph it, you'd go over 3 and then down 2. That would get you a point somewhere like right there. And we went down in the fourth quadrant because the y value is negative. So that's why we have to make sine of theta, this value here, negative, because we are working in the fourth quadrant. If you want to do all the other quadrants, both x and y will be positive here. So cosine and sine will be positive in the first quadrant. In the second quadrant, cosine will always be negative and sine will be positive. In the third quadrant, both will be negative. And then in the fourth quadrant, cosine will be positive and sine, like we just said or learned, will be negative.